Hello, this is a demo for GAM 470, the final project. So right now we have our scene here. You can see that we have skybox, we have terrain models, we have a lake with a beam to reflect everything. We have lights. This one is rotating right now. There are lights that's pointing these models, and we have pre-made models. This crate that is quite familiar. Have imported models, and their models with multiple meshes. So let's talk about the code. First, look at the checklist. Pre-made models. Pre-made models. In the model class and model tools, we I've always created pre-made models. The unit box, which I'm not using. This one, the box with repeating textures, I use that for the crate. Pyramid, didn't use it. The sphere, I didn't use it. The police light, well, this is pretty much the same as the sphere. I modified the sphere a little bit to create this model, so I'm using this one. And in the model class, we can see have this name of these pre-made models as enums, and when I'm trying to render it, I can just pick it and just get a pre-made models. Yes, and also it takes models from files. As you can see here, we have this X. This is the X1, and with models from file, we have this car, these two ships. This police light is a pre-made model. So, and for this X, it is able to handle different meshes. So yeah, talk about this. We have this graphic object. The graphic object it's not like Simon 7, I believe. Now I reduce all 4 into 1, and this one is working beautifully. The shaded language is now in as a shader base, so it can take arbitrary shaders from all these 4. So if you have anything else, I think if it is inherited from the shader base class, it is able to be accepted by this. And this one, based on the number of matches, set all this list and have the value set. I'm able to set the shader like this one. If I just pass in the shader, I will set for all meshes. For example, for this the X, it has 2 meshes, but I'm only changing the materials because they're both using the shaded texture light. They use the same texture because it was originally a 1 mesh model. I split it into 2 meshes so I can have different materials, but they're using the same texture file and they're sharing the same word. And right here, but if I specify the mesh number, I'm able to change the desired mesh. And when rendering here, like how do I be able to adapt to different shader. For example, if I'm using the texture shader, and also we're using the texture light, it's of course going to be some differences. And for example, the texture shader doesn't have anything to do with the materials, and also the texture light has nothing to do with the sand word color. But for this class, I'm running through all these process because I modified the shader base class a bit. I'm adding all these functions from these 4 shader languages, from these 4 shaders, but they're doing nothing here. And well, when in the real shader language, it is going to override the one in the shader base. So actually now it actually do something. So in this case, if I have this shader, I'm able to only the function that works for that shader is going to happen. But anyway, I have all these values stored in here, so I'm able to render the model and only need to get the view and projection matrix together with the device context. So it's really so now rendering objects is pretty neat in the DXApp file. So I just need to, well, of course, every time I try to set the word, because it possibly is going to be changed. Like for these 2 ships, of course they're changing. The car is not, but I just leave it there. And also the terrain and skybox, its functions are really similar, having be able to take the shader and store it. But this one is I didn't use the arbitrary one because I know which one I'm using, and I don't want to change to anything else. This is Skydorm. Oh, this is Skydorm, not Skybox. Okay, so this is Skybox, and rendering that is also takes a shader, and because it has a shader, it's just going to set the context. Everything will be done within this class. So in the DXApp, it was just a 2 line. One set the position and one sets the render. And the terrain model. So this terrain model, I'm using this. I think it's called the Gaussian blur. Yes, to smoothen out the terrain. So it used to be quite bumpy, and now it's a lot smoother. And I'm able to set the normal for each vertex based on the average of all the I take consideration of all 8 vertices around. Although there's only 6 of them that is connected with this vertex, I decide to take all 8 and to calculate the average. The result is it works quite well. And this is terrain model class. And yes, the resolution of this terrain model is based on the resolution of the height map, which I think I discussed this in previous assignment. And so the bigger the height map, the higher resolution of it, the higher resolution of this terrain model would be. But the length is going to be it has nothing to do with the resolution. It's just about the size. Maximum height to set the maximum height. Yeah. So let's look at the shader class and high level shader language. The shader class, I modified something for the shader language. Two parts. The first is the modify to let it able to accept fog. You might not see the fogs in the demo because I didn't have the foggy fog. I have the a black fog to give a sense of darkness. So when I like leaving this a little far away, you can see it turn black, turn dark. So this is so it's not a foggy fog. In order to, also I have multiple lights right here. I'll talk about lights. It's funny because we can now see the headlights of this car is so bright, but actually we're not able to see the light source. So how do I make it happen? Actually, I put 2-point lights just right in front of this headlights with a tiny range. So it's only going to shine on the headlight. Oh, it's right here. Oh, there's a mirrored one, and right here it's only 0.3 in radius. So tiny, it's only to give light to the headlight. So it looks like you can see the light source. Actually, no. And also, I have the directional light moving. So right here, you can see on the roof, and it's roughly pointing to the direction of the moon. So it looks quite nice. So about the fog and the light. Let's first talk about the fog. In order to have the fog, well, we did it in assignment 8. Here it is. This part calculates the fog, and I have it be able to create a structure in here and pass it in as a new instance to the constant buffer. So right here, now the shader has the fog structure, and also it's going to also the graphic object have values to store the fog values, and in the shader language I'm able to pass in the fog value to the constant buffer. So now the shader language can calculate that, then take the values from the buffer. Also the light. The lights is also I need multiple lights, so make this to list, and it can be set by telling the index of it. And the shader language, yes, need to modify a little bit, not much. You just make this into list, and when output, just run through a loop to loop through all cases, to all light sources. And also one thing I noticed about a fog. So see right here, I'm commenting this line out. So why do I do it? Because the fog attribute is actually something to do with the shader, not with the object itself. Because it's about a shader, so, and I'm almost all things I'm using here is using the texture light shader. So I only need to set that buffer, the fog buffer, once, and the only thing I need to update is the word and maybe the material. Yes, the material, because they will be different for different models, objects, but the fog is going to be universal because everything in the world, I want them to use in the same fog value. It will be more realistic, I think. So when I initialize the shader language, the shader, I set the fog value right after I initialize that, and then it is done. I do not have to set it every time. I do not have to set it in rendering because it is already in the buffer. But if I want to let multiple objects have different fog value, I will need to uncomment this line and use that. And by the way, these fog values, they have default values. When I initialize that, default is set to infinity, so it will not be reached unless I assign a specific value. Because this is set there, so every time it rendered, it will pass this infinite number to the buffer, and nothing will happen because we're not going to touch the infinity. Okay, so that is all for the shader. And graphic object, yes, I just mentioned that. The mirror, yes, the mirror. I have the mirror working right now, which I demoed that in assignment 8. But I modified it a little bit, so now the mirror is acting like any other class that is able to store the shader. I'm using the shader color. I'm stick to this one because I don't want the water to reflect light. Well, yes. And also I'm using the shader color, and also because I'm using the shader color, and the lake, the mirror is actually reactive to the fog, I changed something to the color selected shader language, because rendering the fog in a shader language that has light is easier because we already have a very vital attribute that is called the eye position, I believe. Yes, this eye position word, because this is I need this eye position to calculate the distance between me and the pixel, so I can tell what level of fog I need. But it was not in the color selected class, so I not only had the fog, I also added another buffer just to pass in the eye positions. And so right now I'm passing the eye position and the word, and the fogs only need to pass once. And yes, and it's not only vertex shader, now it has something to do with the pixel shader. And so when it came out, I be able to have the fog value added to it. So the mirror have the shader taken. It's initialized everything here. Because I have the shader here, stored many things. So right now in the DX app, when trying to render the not render the mirror, but to activate the mirror, it's a one-liner here. So just passing the attribute needed to set it on and set it off. And between it is everything I want to be shown in the mirror. Of course, add the reflection matrix after every thing that is related to positions. Okay, so then the render terrain. So pretty much that's it. Oh, also the skybox I'm having right now is, I need to show that this texture is actually having two meshes. The metal part is shiny, the wooden handle not very. And yeah, what I want to say, yes, the skybox is right now following the position of the camera. So, because it is spinning, but if it's not spinning, you was not able to see the skybox moving, because in that way the problem of this edge of the skybox is minimalized, because but also I try to use the sky dome. I'm having trouble to find the perfect texture to it. So right now the sky dome is having a texture that is not that great, but it's still okay. And I should probably set the position same as the skybox, so you'll be following me around. It's kind of neat. So now, yeah, we have a sky dome here. Oh, it looks so beautiful. The starry night with a strange alien things going on, and also reflects. But there's some problem because I couldn't find the perfect texture. So yeah, you can see the texture on the upper half, the dome is good, perfect. But also this ugly side when it go be beyond the horizon. So if I'm using sky dome, I will mostly prefer to stay on the ground. So the mountains, the hills, going to block the ugly part. Yes. And pretty much that's it. That's it for the demo. Thank you.